Some recurring decimals have one decimal place and one dot, or could be two decimal places and two dots. It might be that there are two decimal places but only one dot. Perhaps three decimal places where there are two dots but they might or might not be next to each other. Firstly, we need to know what these numbers would be expanded. The dot above the 3 in 0.3 means that the 3 is repeated forever. As there are dots above the 3 and the 9 in 0.39, the 3 and the 9 are repeated. In 0.53, only the 3 is repeated as the 5 doesn't have a dot. In 0.239, only the 3 and the 9 are repeated. And in 0.479, all the numbers from the first to the last dot are repeated, so 4, 7 and 9 are all repeated. In all these questions, I like to get the decimals the same, so that when one is subtracted from the other, it completely eliminates the decimals. For example, if we let 0.3 dot equal x, we can multiply it by 10, getting 10x equals 3.3 dot, and they both have the same decimal places. Subtracting x from 10x, we get 9x equals 3. And using algebra, by dividing both sides by 9, we get x equals 3 over 9, which cancels to 1/3. Here are two more similar examples. In this example, if we let 0.39 both repeating equal x, then in order to get another number with the same decimals, we need to multiply 0.39 by 100, getting 100x. Subtracting x from 100x, we get 99x equals 39. And then using algebra, by dividing both sides by 99, we get x equals 39 over 99, which cancels to 13 over 33. Here are two more similar examples. In this example, if we let 0.53 with the 3 repeating equal x, then in order to get the same decimals, we need to multiply twice, once by 100 getting 100x and once by 10 getting 10x. Subtracting 10x from 100x, we get 90x equals 48. And using algebra, by dividing both sides by 90, we get x equals 48 over 90. This cancels to 8 over 15. Here are two more similar examples. In this example, if we let 0.239 with the 3 and the 9 repeating equal x, then in order to get the same decimals, we need to multiply twice. Once by 1,000 getting 1,000x and once by 10 getting 10x. Subtracting 10x from 1,000x, we get 990x. And using algebra, by dividing both sides by 990, we get x equals 237 over 990, which cancels to 79 over 330. Here are two more similar examples. These are other ways it could be written. So if we let x equals 0.479, where the 4, 7 and 9 are all repeating, then in order to get another number with the same decimals, we need to multiply x by 1,000, getting 1000x. Subtracting x from 1000x, we get 999x equals 479. And using algebra by dividing both sides by 999, we get x equals 479 over 999. Here are two more similar examples.